Today, let's discuss basic differentiation rules. First one, I'm going to call it the constant rule. This rule states the derivative of a constant function is 0. That is, if c is a real number, then the derivative of c is 0. Next rule, the power rule. Probably one of the most important rules. If f of x equals x to the nth power, then the derivative of f of x equals n x to the n minus 1. Or more simply, the derivative of x to the nth power is n x to the n minus 1. So let's look at some examples here. So the derivative x squared is 2x to the 1, which is 2x. Derivative of 3x squared is 6x. Derivative of x to the 7th, 7x to the 6th. The derivative x to the 3 halves is 3 halves x to the 1 half, or 3 halves root x. These are all typical examples you'll see. Of course, we should also mention the derivative of x we can write as 1 times x to the 1 minus 0, which is simply going to be 1 times x to the 0, which is simply 1. So the derivative of x, you can recall, is just 1. Let's call this the constant multiple rule. F is a differentiable function, and c is a real number, then CF is also a differentiable function, and the derivative of CF of x is c times the derivative f of x. Wonderful. So we can simply multiply by the constant whenever we're differentiating. This is great because this means that say when we take the derivative of 3x squared, this is 3 times the derivative of x squared. So it's 3 times 2x, which of course is 6x. So this is we often use this without directly stating that we're using it, but I find it's helpful to think of it explicitly when we're first learning to differentiate. Let's see. If we look at, say, the derivative of 2 root x, this is going to be 2 times the derivative of root x. And root x, of course, we can write as x to the 1/2. And so this turns into 2 times 1/2 times x to the minus 1/2. And this simply turns to x to the minus 1/2, which is 1 over x to the 1/2, which is 1 over root x. So to write that all on one line, the derivative of 2 root x is 1 over root x. So this rule is actually quite essential and quite important. Let's talk about the sum and difference rules next. The sum or difference of 2 differentiable functions is differentiable. And is the sum or difference of their derivatives. So, in other words, the derivative of a sum is the sum of the derivatives. This is a rather natural rule. Of course, the derivative of a difference is the difference of derivatives. Very lovely. So let's take a typical example. If we take the derivative of x cubed minus 4x plus 5, we can write this as the derivative of x cubed minus the derivative of 4x plus the derivative of 5. Often, again, we don't explicitly write this out, but it's great to think about this when we're first learning. This is going to be 3x squared minus 4 plus 0. So we obtain 3x squared minus 4. Lovely.